Hi learners! This video lesson deals with solids called cylinders, particularly right circular cylinders and oblique circular cylinders. Getting and comparing their volumes is discussed and demonstrated. Determining the shapes of the cross-sections as well as comparing the areas of the cross-sections of right circular cylinders are also showcased. Strategies in analyzing and solving problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on cylinders, or if you have an assignment on this topic, or if you're preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Look at these learners. Familiar, right? What you have is an example of a cylinder. This cylinder has two parallel circular bases connected by this curved surface. The distance between these two circular bases is its height. The distance from the center to the outer boundary of its base is its radius. The line connecting the centers of the two bases is its axis. Aside from batteries, the common objects that are cylinder or cylindrical in shapes are tree trunk, branches of most plants, candles, container of most stuff in the kitchen, like canned goods and spices, and coffee mug, to name a few. I am sure you can also name some, learners. Now, there are many types of cylinders, but we will only focus on circular cylinders, the right circular cylinders, and oblique circular cylinders. A right circular cylinder is a cylinder where the axis is perpendicular to the center of its base, while an oblique circular cylinder is where the axis is not perpendicular to the center of its base. That is, the axis forms an angle other than a right angle with the center of its base. In the video, when we say right cylinder, we mean right circular cylinder. Likewise, when we say oblique cylinder, we mean oblique circular cylinder. Cylinders are three-dimensional. It has length, width, and height. Thus, its unit of measure is cubic units of length, like cubic inches, cubic feet, cubic meters, and so on. How do we measure the amount of space occupied by a cylinder? That is answered by getting its volume. Now look at these learners. What do you see? You're correct. We have a circle. A circle is a 2D flat surface. It has no thickness. Thus, the amount of space it occupies is described by its area with unit measures in square unit, like square inches, square centimeters, and so on. As height builds up, as what we have here, the once just a 2D flat surface is gaining thickness. A third dimension is being added, the height. We do not only have the flat 2D circle now, but a 3D solid, a right cylinder. This idea is where the formula for the volume of a right cylinder came from. Thus, the volume of a right cylinder is B times H, where B is the area of the base of the cylinder, which is a circle, and H is the height of the cylinder. Since the area B of the circle is pi r squared, then the volume of the cylinder is pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. You have to remember this, learners. For us to be able to determine the volume of a cylinder, we should know the values of r, the radius of the cylinder, and h, the height of the cylinder. Now, what about the volume of an oblique cylinder? How is it determined? Let us look at what we have here. We have here a right cylinder and an oblique cylinder. What do they have in common? Well, they're both circular cylinders. Okay, I want you to observe these carefully, learners. What did you notice about their height? Correct, they have the same height. What about their bases? How will you compare their bases? You're right again. They have congruent circular bases. Since the bases are congruent, what can you say about their areas? Okay, so the area of the base of each cylinder are the same. Now, if they have the same areas, what is true about the radius of each circular base? Great! The radius of each circle are equal. Now, if two circles are congruent, that means that they have the same area, right? And if they have the same area, it implies that they have the same radius. Do you agree? Okay, let us not forget that we want to know how the volume of an oblique circular cylinder is obtained. Now, I want you to look at this, learners. Do you still see two cylinders here? Okay, so we have here the right cylinder, and here is the oblique cylinder. Now, we will move this part of the oblique cylinder and put it on the left like this. What do you see? Okay, so you see a right cylinder, correct? This time, we will move this part of the right cylinder and put it on the other side like this. What do you see? Okay, this time you see an oblique cylinder. From your observations, what can you say about the amount of space occupied by the cylinders? You are correct. With the same height and the same bases, the amount of space occupied by the right cylinder is the same as the amount of space occupied by the oblique cylinder. Since the amount of space occupied is the volume, then we say that the volume of a right cylinder is the same as the volume of an oblique cylinder when the height and the radius are the same. Thus, the formula for the volume of an oblique cylinder is the same as the formula for the volume of a right cylinder, which is pi r squared h. I hope you are able to follow, learners. Okay, let us try this sample problem. Here's the problem. A cylindrical tank shown is to be filled with water. How much amount of water will the tank hold? Round your answer to the nearest tenth in cubic feet. A figure is given, and here are the options. Option A, 9.0 cubic feet. Option B, 18.8 cubic feet. Option C, 24.0 cubic feet. Option D, 28.3 cubic feet. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What is asked in the problem, learners? You're correct. We're asked to find the amount of water that the tank can hold. What are given? We're given a figure of the water tank with its height and radius. Okay, so we're to find the amount of water, which is the volume of water that the tank can hold. The tank is cylindrical in shape, so we have to have the formula for the volume of the cylinder. Okay, so with the formula, we plug in the values. We have multiplying 1.5 feet to itself gives us 2.25 square feet. Multiplying 2.25 square feet to 4.0 feet gives us 9.0 cubic feet. Using 3.14 for the value of pi and multiplying it to 9.0 cubic feet gives us 28.26 cubic feet. Rounding off the number to the nearest tenth gives us 28.3 cubic feet. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Let us now investigate the cross-section of the right cylinder. Recall that a cross-section is a 2D surface obtained upon slicing or cutting through a 3D figure or solid. An extensive discussion on this topic is in our video lesson on geometric solids, prisms, volume, and cross-section. The link is down below. Let us slice our right cylinder here parallel to its base and see what shape will its cross-section be. Let's go. Okay, so the cross-section is circular in shape and is congruent to its base. Did you see that, learners? Now let us move on with this second sample problem. Here's the problem. Consider the right cylinder below. If the cylinder will be sliced perpendicular to its base, what would best describe its cross-section? A figure is given. Option A, circle. Option B, square. Option C, rectangle. Option D, semicircle. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What is asked in the problem, learners? You're correct. We're asked to determine the shape that would best describe the cross-section of the right cylinder sliced perpendicular to its base. What are given? We're given a figure of a right cylinder. Okay, so this is what we'll do. We will slice the cylinder perpendicular to its base to see what the cross-section is. Let's go. There you are, learners. So what is our answer here? Is it option A, option B, option C, or option D? Okay, so the answer is option C. Okay, let us do sample problem 3. Here's the problem. Two cylinders, A and B, each with height of 35 inches are shown. The radius of cylinder A is K, while the radius of cylinder B is L. Which statements about cylinder A and cylinder B are true? Option A, if K is equal to L, the volume of cylinder A is greater than the volume of cylinder B. Option B, if K is equal to L, the volume of cylinder A is equal to the volume of cylinder B. Option C, if K is equal to L, the volume of cylinder A is less than the volume of cylinder B. Option D, if K is less than L, the area of the horizontal cross-section of cylinder A is greater than the area of the horizontal cross-section of cylinder B. Option E, if K is less than L, the area of the horizontal cross-section of cylinder A is equal to the area of the horizontal cross-section of cylinder B. And option F, if K is less than L, the area of the horizontal cross-section of cylinder A is less than the area of the horizontal cross-section of cylinder B. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to determine which statement about the volume and the cross-section of cylinder A and cylinder B are true given the diagram. What are given? We're given a diagram of the two cylinders with some values. Okay, so we have two cylinders here. One is a right cylinder and the other one is an oblique cylinder. Look at the diagram, learners. What can you say about their height? You're correct. Both have the same height, 35 inches. How about the radius of each cylinder? The radius of cylinder A is represented by K, whereas the radius of cylinder B is represented by L. Since K and L are variables, their values may vary. Now, do you remember what we learned earlier about the volume of the right and the oblique cylinders? Okay, so we learned that the two cylinders have the same volume when they have the same height and the same radius. So, what we will do is analyze the statements comparing their volume first, then evaluate the given conditions about the radius, and conclude if the statement is true or not. Let's go. Okay, we will start with option A. The statement is, if K is equal to L, the volume of cylinder A is greater than the volume of cylinder B. Now, is the statement true or false? Okay, so option A is false. We move on to option B. The statement is, if K is equal to L, the volume of cylinder A is equal to the volume of cylinder B. Now, is the statement true or false? Okay, so this is true. The height is the same, the radius is the same, so the volume of each is the same. How about option C? The statement is, if K is equal to L, the volume of cylinder A is less than the volume of cylinder B. So definitely this is false. The next three statement compares the area of the cross sections. Remember that the horizontal cross section of the cylinder is a circle, and the area of the circle depends on its radius. Let's go and examine the next three statements. For option D, the statement is, if K is less than L, the area of the horizontal cross-section of cylinder A is greater than the area of the horizontal cross-section of cylinder B. Is the statement true or false? Okay, so false. For option E, the statement is, if K is less than L, the area of the horizontal cross-section of cylinder A is equal to the area of the horizontal cross-section of cylinder B. Is the statement true or false? Again, this is false. For option F, the statement is, if K is less than L, the area of the horizontal cross-section of cylinder A is less than the area of the horizontal cross-section of cylinder B. Is the statement true or false? You are right, the statement is true. Here in option F, radius K is lesser than radius L, suggesting that the circle with radius K is smaller in size. Since the circle is smaller, its area will also be lesser. So, what are our answers again? Okay, so our answers are option B and option F. There you are, learners. I hope that you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a cylinder is a 3D shape having two parallel circular bases connected by a curved surface. Second, a right circular cylinder is a cylinder where the axis is perpendicular to the center of its base. Third, an oblique circular cylinder is a cylinder where the axis is not perpendicular to the center of its base. Fourth, the volume of a cylinder is pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. Fifth, the unit of measure for the volume of a cylinder is in cubic unit of length, like cubic feet, cubic meters, cubic inches, etc. Sixth, the volume of a right cylinder is the same as the volume of an oblique cylinder when they have the same height and radius. Seventh, the cross-section of a solid is a 2D surface obtained upon slicing or cutting through the solid. When a right cylinder is sliced parallel to its base, its cross-section is circular in shape and is congruent to its base. When a right circular cylinder is sliced perpendicular to its base, its cross-section is rectangular in shape. 8th, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. 9th, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye!